You think space is empty? Look, I'm going to tell you something that's going to bother you. It bothered me for years, and frankly, it still does. We look up at the night sky. We see these vast distances between stars, between galaxies, and we say, oh, that's empty space. That's nothing. Nothing. Let me tell you what's actually there. In every cubic centimeter of what you call empty space, and I mean every single one, there are particles popping in and out of existence so fast that you can't even see them. They live for a fraction of a second so small that it makes a nanosecond look like an eternity. They're called virtual particles, and they're everywhere. But here's the disturbing part, and I mean really disturbing. These particles that don't exist are affecting everything. They're changing the properties of electrons. They're shifting energy levels in atoms. They're making your reality what it is. So when you point to empty space and say there's nothing there, you're more wrong than someone who thinks the earth is flat. At least the flat earther is wrong about something that exists. You're wrong about something you think doesn't exist at all. Now let me explain why this should terrify you. You know what the problem is with most people? They trust their eyes. They look at a glass, they pour out the water, and they say, now it's empty. Then they're satisfied, like they've accomplished something. Empty glass. Job done. But let me ask you this. What's in that glass now? Air, you say. Fine, good answer. So we pump out the air. We create a perfect vacuum. And by the way, creating a perfect vacuum is incredibly difficult, which should already tell you something. Now, what's in the glass? This is where most people get uncomfortable. Nothing, they say, but they say it like a question, because deep down, something doesn't feel right about that answer. And they're correct to feel uncomfortable, because the answer isn't nothing. The answer is never nothing. Let me take you back to when I first learned about this. It was in the 1940 seconds, and we were working on quantum electrodynamics, QED for short. We were trying to understand how light and matter interact, how electrons behave. Basic stuff, except it wasn't basic at all. Every time we did the math, we kept getting these infinities. Infinities. The equations were telling us that certain quantities should be infinite, which is nature's way of telling you that you've done something terribly wrong. But here's what we discovered. The vacuum isn't empty. It can't be empty. If it were truly empty, the math would work out nice and clean. But it doesn't. The vacuum is seething with activity. Think about it this way, and I want you to really think about this, not just nod along. According to quantum mechanics, you cannot know both the position and momentum of a particle with perfect precision. That's Heisenberg's uncertainty principle. But here's what most people don't realize. The same principle applies to energy and time. What does that mean? It means that if you look at a very small interval of time, and I mean very small, like 10⁻21 seconds, the energy in that moment can fluctuate wildly. Energy can appear out of nowhere as long as it disappears quickly enough. It's like borrowing money from the universe as long as you pay it back before the cosmic accountant notices. And what does energy become? Mass, E equals mc squared. Remember? So in these tiny fractions of time, particle-antiparticle pairs are constantly appearing and annihilating throughout all of space. An electron and a positron pop into existence. They exist for an impossibly brief moment, and then they destroy each other. Poof! Gone. This is happening everywhere. Right now, in the space between your eyes and this screen, countless particles are blinking in and out of existence in the space inside your body, in the space between the atoms that make up your body, everywhere. Now you might say, okay, Richard, but if they appear and disappear so fast and we can't see them, do they really matter? Aren't they just a mathematical curiosity? Oh, they matter. They matter more than you can imagine. These virtual particles, we call them virtual because they don't stick around long enough to be directly observed. They have real, measurable effects on reality. Let me give you an example that proved this beyond any doubt. In 1947, Willis Lamb discovered something strange. He was looking at the energy levels in hydrogen atoms, the simplest atom, just one proton and one electron. According to Dirac's beautiful equation, two particular energy states should have been identical. They should have had exactly the same energy, but they didn't. There was a tiny difference, a shift that nobody could explain unless you accounted for the virtual particles. You see, when an electron is sitting there in an atom, it's not just sitting in empty space. It's sitting in this roiling sea of virtual particles. These particles pop up, they interact with the electron for the briefest moment, and then they vanish. But each interaction gives the electron a tiny little kick, and when you add up all these kicks, billions upon billions of them happening every instant, you get a measurable shift in the energy level. We calculated this shift using QED. We included all the virtual particles, all their brief lives and deaths, all their fleeting interactions. And you know what? Our calculation matched Lamb's measurement to an absurd degree of precision, something like 1 part in a billion. That's when we knew. This wasn't just mathematics. This wasn't just a trick to make our equations work. The vacuum really is full of these ghostly particles, and they really do affect everything. But here's where it gets truly disturbing, and I mean this in the deepest sense. These particles that exist for less than the blink of an eye, these particles that we call virtual, as if they're somehow less real, they are absolutely essential to the functioning of the universe as you know it. The electromagnetic force, the force that holds atoms together, that makes chemistry possible, that allows your neurons to fire so you can read these words, that force is transmitted by virtual photons. Not real photons like the light you see, but virtual ones that pop up between charged particles and vanish immediately. In a very real sense, you are held together by things that don't exist. Every electron in your body is constantly surrounded by a cloud of virtual photons and virtual particle pairs. These affect the electron's properties, its mass, its charge, everything about it. If you tried to strip away these virtual particles, if you tried to look at a naked electron without its cloud, you'd find that its properties are completely different. So what is an electron, really? Is it the bare particle at the center, or is it the whole package including the cloud of virtual particles? The answer, disturbingly, is that the question doesn't make sense. The electron is the cloud. You cannot separate them, even in principle. This is what I mean when I say space is not empty. Space is the most active place in the universe. Now, if what I told you in part 1 disturbed you, then buckle up, because we're about to go deeper into this rabbit hole, and I promise you, the bottom is nowhere in sight. Let's talk about what happens when you look at space at even smaller scales. I mean really small scales, scales so tiny that they make atoms look like galaxies. We're talking about the Planck length, which is about 10 negative 35 meters. That's a decimal point followed by 34 zeros and then a 1. At that scale, space itself starts to do something absolutely bizarre. It foams. Yes, you heard me right. Space foams like beer, except this foam is made of geometry itself twisting and writhing. We call it quantum foam or space-time foam. And John Wheeler, brilliant guy, one of my heroes, he was the one who really pushed this idea. At the Planck scale, the uncertainty principle becomes so extreme that space and time themselves become uncertain. The fabric of reality is bubbling with microscopic black holes appearing and disappearing, with little wormholes connecting different points in space-time, all of it churning in a frenzy of quantum chaos. Think about that for a moment. The stage upon which all events occur, space itself, is not a calm, flat stage. It's more like the surface of the ocean during a storm. If the ocean were infinitely more violent and the storm were happening at scales billions of times smaller than an atom. But here's what really keeps me up at night, and this is something that we still don't fully understand, even now. all those virtual particles I told you about, they have energy. Each one, during its brief moment of existence, carries energy. And when you try to calculate how much energy is in the vacuum, just sitting there in empty space, you get an answer that is so large, so monumentally, catastrophically large, that it should cause the entire universe to collapse into a black hole immediately. I'm not exaggerating. When you do the calculation properly, taking into account all the possible virtual particles at all possible energy scales, you get an energy density for the vacuum that is about 120 times larger than what we observe. That's not 10 times larger, or 1,000 times, or 1,000,000,000 times zeros. It's one followed by 120 zeros times larger. This is called the cosmological constant problem, and it's the biggest mismatch between theory and observation in the history of physics. It's not even close. It makes every other problem in physics look like a rounding error. Something is wrong. Either our quantum field theory is catastrophically wrong about how to count vacuum energy, or there's some mechanism, something we don't understand, that cancels out almost all of this energy. But not quite all of it, because recent observations show that empty space does have a tiny amount of energy, causing the universe to expand faster and faster. We call it dark energy, but really we have no idea what it is. So, let me get this straight, and I want you to appreciate the absurdity here. Space is filled with energy from virtual particles. We can measure the effects of these particles. They shift energy levels in atoms. They affect the magnetic moment of the electron to 11 decimal places. Every test we do confirms that they're real. But when we try to add up all their energy, we get a number that's so wrong that it's laughable, except nobody's laughing because we can't figure out why it's wrong. This is nature telling us something profound. We're missing something big, something fundamental. Now, let me tell you about another disturbing consequence of all this. You know what holds protons together in the nucleus? The strong nuclear force. We call it. But here's the thing. This force is also transmitted by virtual particles, specifically virtual gluons and virtual quarks that pop in and out of existence between the quarks inside the proton. And get this, when you try to calculate the mass of a proton, most of it doesn't come from the quarks themselves. Most of the mass comes from the energy of these virtual particles. About 99% of your mass, of the mass of everything you can touch and see, comes from the churning energy of virtual particles inside protons and neutrons. You are made of energy borrowed from the vacuum. Your body, your brain, your bones, 99% of the mass that makes you you is energy from particles that exist for unimaginably brief moments, energy that's constantly being borrowed and repaid in an endless quantum transaction. In a very literal sense, you are made of nothing. Or rather, you're made of what we mistakenly call nothing, which turns out to be the most energetic, most active, most fundamentally important thing in the universe. Here's another thing that bothers me. We talk about forces, electromagnetic force, nuclear force, gravity, but in quantum field theory, forces are really just the exchange of virtual particles. When two electrons repel each other, they're not really pushing each other in any classical sense. They're exchanging virtual photons. The photons appear, travel between the electrons, get absorbed, and disappear. The exchange of these particles that don't quite exist is what creates the force. So forces themselves are illusions, or rather, they're emergent properties of virtual particle exchange. Everything that happens in the universe, every interaction, every event, is fundamentally about these ghostly particles appearing and vanishing. The Casimir effect is maybe the most direct demonstration of vacuum energy that anyone can understand. Take two metal plates and put them very close together in a vacuum. The plates will attract each other. Why? Because the space between the plates is so narrow that only certain virtual particles can fit in there. Outside the plates, all possible virtual particles can appear. So there's more vacuum pressure outside than inside, and the plates get pushed together. We can measure this force. It's real. It's been confirmed in laboratories around the world. The nothing between the plates is less nothing than the nothing outside the plates. And this difference in nothing creates a measurable force. That's perhaps the most profound thing I can tell you. We've learned to manipulate nothing. We've learned that nothing comes in different varieties, different flavors of emptiness, and these differences have physical consequences. So when someone points at the sky and talks about the vast emptiness of space, I want to grab them and say, look, there is no emptiness. Every point in space is a seething cauldron of activity happening at scales so small and so fast that you can't see it. But it's there, and it's real, and without it, you wouldn't exist. The universe isn't mostly empty space, with a few particles scattered here and there. The universe is an infinite ocean of quantum activity, and the particles we see, the ones we think of as real, are just the tiniest ripples on the surface of this ocean. That's the disturbing insight. Nothing is something, empty is full, and the vacuum is the most important thing in physics.